Alright, today we're going to be dealing with right-hand rule. It seems like a lot of you are having issues with right-hand rule types of problems, but right-hand rule really boils down to two different types of rules. So if we can learn those two different types, then we should be able to get any right-hand rule problem that comes our way. So let's try it. Let's take the easiest type of right-hand rule first. This is right-hand rule number one. Right-hand rule number one. So in this case, this is when you've got a current carrying wire, something like this. This is just a straight segment of wire, and what you do is you take your thumb of your right hand. Since we're dealing with the right hand rule, you always want to use your right hand. You're going to put your thumb in the direction of the current. So in this case, your thumb is going to go like this along that current carrying wire. And then the B field that's created due to that current carrying wire will just wrap around the wire like this. So in other words, if your wire is like this and you have some sort of a current traveling upwards, then you would put your thumb like this and you could imagine a circular B field, a circular magnetic field around this wire. So in this case, it's going to kind of look something like this. So here is the B field due to that current carrying wire. Now another way that I could draw this if I wanted to, I might only be interested in, say, one side or the other of this wire, right? So I could, for example, instead of drawing it this way, I could have instead drawn my B field like this. So let me draw my current carrying wire again. I could draw my B field, so in this case it would be going into the page on this side. So into the page, I draw like an X, because it's supposed to look like the tail of an arrow going away from you. And then on the other side of the wire, it's coming out at us. And so in this way, I would draw the B field as like a little circle with a dot in the middle of it. It's supposed to look like an arrow coming out towards us. So to the left of this wire, the B field's coming out of the page. To the right of this wire, the B field's going into the page. So that's the first type of right-hand rule. So this is a really nice way of dealing with straight segments of wire. But there is a little trick. There's a little trick when you're dealing with circular types of wire. So for example, if I had a type of wire that looked like this, and the current was traveling around counterclockwise, then we could use our straight segment right-hand rule all the way around this entire wire. In that case, I would just put my thumb along the wire like this, and you can imagine the B field kind of wrapping its way around so that anywhere in the center of this circle, the B field is going to be coming out at us. So all the way around this entire circle, the B field is coming out at us like that. And anywhere outside the circle, the B field is going into the page, like this. So the B field is going into the page, and technically, I should be labeling each of these blue dots and X's as a B field, but you kind of get the idea here. So that's one way of dealing with the right-hand rule when you're dealing with it in a loop. But again, there is this trick where you can effectively invert what you're calling your I, your current, and what you're calling your B. So before we were putting our thumb along current and our forefingers along B. But when you're dealing with a loop, it's even easier to take your forefingers and wrap them in the direction of I, and then inside of I you can see here this B field's coming out of the page at you, and so now your thumb acts like B. So either way you want to go, if you want your thumb to act like current and your forefingers to wrap around like B, or the other way around, it's totally okay. So that's how you deal with right-hand rule number one. So there's no real equation involved here, it simply gives you the B field due to a current carrying wire, either straight or a loop. Now let's try right-hand rule number two. Right-hand rule number two is the one that you're going to use pretty much any time that you're dealing with cross products. So right-hand rule number two. So for example, the one that you guys tend to see all the time is something like this. So F equals QV cross B. So there's one of the equations that you see all the time crop up in the homework assignments, on test practices, and things like that. So here's the trick with this one. This is the way that I tend to think about it. What we're going to do, and I'm going to write it out before I do it, is I take 4 fingers of my right hand, of course, 4 fingers, put them in the direction of Q times V, so you have to consider whether or not Q is positive or negative. You're going to sweep them in the direction of B, and then your thumb will land in the direction of force. Okay, so that's the plan. So that's how we're going to handle these sorts of problems. So let's just come up with something kind of on the fly here. So let's suppose that let's keep it easy, let's suppose it's a positive charge that we're dealing with, and maybe it's got, for whatever reason, some sort of a velocity to the right. So it's moving to the right like this. Then in that case, we need to have been given some information about a B field. Let's suppose in this entire region that the B field is into the page. So here I'm drawing my circles with X's here to indicate that my B field is into the page. So what I want to do is I take my right hand and I keep it flat, like you're playing rock, paper, scissors, but this is the paper, okay? So it's a flat kind of karate chop action right hand, okay? And now what I'm going to do is I'm going to take these 4 fingers, and like I promised, we're going to put them in the direction of Q times V. So Q is positive here, and V is to the right. So if I take some positive number and I multiply it by a vector pointing to the right, I'm still going to get a vector pointing to the right. Okay, so Q times V in this case is just to the right, like this. So that's kind of nice, that's easy. Now I cross it in the direction of B. So B is into the page, so what I'm going to do is I'm going to sweep these 4 fingers in the direction of B. So what that means is I'm going to bend at this knuckle right here, the big knuckle closest to my palm. I'm going to bend them into the page. And so now they're pointing in the direction of the B field. And so now it has to be that my thumb is pointing up, and so the force felt by this proton, or this positive charge, whatever it is we're dealing with here, due to that B field, must be pointing up, like that. So again, Q times V, I've got my flat right hand like this, and I have a lot of options, right? I could have put it like this, for example. But now if I want to get my 4 fingers to sweep in the direction of B, I have to rotate it and bend them into the page like this, and now that leaves me with my force, my thumb, pointing directly up. And so that's what gives me the direction of force in this right hand rule. Okay, so how would this change if you had a negative charge? Well, if you have a negative charge, here's what happens. Here's your negative charge. So V was pointing to the right, still is pointing to the right. Q is negative. So this vector, Q times V, is not pointing to the right, now it's pointing to the left. So Q times V is pointing to the left. Now I sweep my 4 fingers in the direction of B, that's still into the page, like this. And now my thumb is pointing down. So I get the exact opposite direction that I got with the positive charge. So that's how the second right hand rule works. And so we can use this any time that we're given any sort of cross product equation. We can take 4 fingers, put them in the direction of the first bit, then sweep them in the direction of the second bit, and then our thumb is pointing in the direction of this thing that is on the left-hand side of the equal sign. So let's try another example. This one not involving a charge. This one's going to use a slightly different equation. So instead of QV cross B, I'm going to use IL cross B. So you might have seen this one before. All right, so this one is going to be IL cross B. I'm going to leave all the rest of this description up here because it's all exactly the same. But this one is great when you've got a current carrying wire in an external B field. So let's see how this one's going to work. So suppose that I have, let's say, a current carrying wire like this. It's pointing up. Now what we said initially, right, when the video started, we talked about the B field that was actually created as a result of this current carrying wire. So that's still there. But what we're interested in now is the force on this current carrying wire due to some external B field. So some other B field other than this one that's going circularly around this wire. Okay, so let's, I'm going to make something up here. So let's say, let's say we've got a B field, let's say it's into the page. So here's my B field, it's into the page. All right. Now, one of the things you'll notice is that every time that I create one of these questions, I make sure all my vectors are 90 degrees apart. Otherwise, you're going to run into some issues. Okay, so I have I times L. So here we go. So let's practice our right-hand rule. So I times L is just literally in the direction of current. So I times L is up, like this. B is now into the page, so I take my 4 fingers and I sweep them in the direction of B, and that leaves me with a force now. So again, my B is into the page, like this. It's actually pointing into the board. And now that leaves me with a force, which has to be to the left. So this whole wire is experiencing a force due to that external B field, which is to the left. All right, excellent. So things are starting to look good here. Now, some really tricky questions will combine 2 different types of right-hand rule. So let's try one of those. So this comes from, I think it was practice test 2, test B, and I think, I guess I'm not sure. I think I'm sorry, practice test 2E, question 17. Okay, so let's just try this one really quickly. So let's say we've got a current carrying wire, which is like this. Here's your current carrying wire. And then they say there's a little negative charge, like that, and it has some velocity to the right, like that. And it asks you about the magnetic force experienced by this charge. So you're looking at this question and you're thinking, what magnetic force are they talking about? There's no magnetic field in this problem. All they gave me was a current carrying wire and this moving charge. So where is the B field coming from? So the B field, if you might remember, let's first use right-hand rule number 1 to come up with the B field around this current carrying wire. So here's my current carrying wire. I put my thumb in the direction of the current carrying wire, and then my 4 fingers will loop around that wire in the direction of the B field. So there's actually a circular B field around this wire. So what I'm really interested in is, what is the B field right at this point up here where that charge is going to experience that B field? So above the wire, the B field is out of the page. Below the wire, the B field's into the page. So that's fine. We can draw that. We might or might not use it. So there's my B field like that. And my B field out here is going to be out of the page. Okay, so notice that I've drawn the circle with the dot in the center there to represent that it's coming out at us. Okay, so now I have a negative charge, and I want to remember what my equation said. My equation said F equals QV cross B. So Q times V, well, V is to the right, very clearly. Q is negative, so Q times V is to the left. So now I have my 4 fingers to the left. B is now out of the page, so I need to rotate my hand around so that I can sweep my 4 fingers out at you. And so now my B field's out of the page, and that leaves me with a force, which is up. So here, the force from the magnetic field due to this current carrying wire is going to be felt by this negative charge as pushing him up. So that's how the right-hand rule works. Good luck.